Hello students, how are you? Are you alright? Okay. Try to be happy in this situation and also help to others remain happy. This is our responsibility. So today we will discuss the important topic, that is isotopes and isobars. This is also very important concept in atomic structure. And before that, isotopes and isobar, let us discuss some terminology, that is what is atomic number. Atomic number of element is represented by Z. The symbol is represented by Z. Atomic number. Atomic number means Z equal to number of protons. Z of any atom or ions indicates the number of protons, that is called Z. That is the representation of Z. Then atom mass number. Mass number is represented by M, that is capital M. What is M? M is equal to sum of proton plus neutron. This is your mass number, and this is also called as nucleus. This is also called as nucleus. Nucleus means the part of the nucleus, that is sum of proton and neutron of the atom or any ionic species. So that is mass number. So how the atom is represented? Having atomic number and mass number. Every atom has some atomic number and mass number. That means it has some proton and it has also some proton plus neutron inside the nucleus. Some nuclear part and what are an extra nuclear part. Extra nuclear part, that is your electrons, and a nuclear part, that is your proton and neutrons. So if atom is A is the atom, and its mass number is M and atomic number is Z. This is the representation. The representation of atom, showing atomic number and mass number. M is the mass number, Z is the atomic number. Okay? So, for example, let us take hydrogen, H11. What does it mean? Atomic number 1 and mass number also 1. Like this. Suppose carbon, C612. Atomic number is 6 and mass number is 12. So, these are some representation of atom, showing atomic number and mass number. But the atomic number of the atoms of the particular element always remain the same. If we tell that carbon 6 is always, it has atom number 6. We not necessary to tell carbon 6. We can show the mass number. Mass number will vary, but atomic number of the atoms of the same element always same. So H11, C612, like this, these are the representation of the atoms, showing atomic number and mass number. Then what is the isotopes? These are some important species of the element. These are some of the parts of the particular elements. Isotopes, you can say, isotopes means atoms of the same element. Atoms of the same element. Same element having same atomic number, but different mass number. Atoms of the same element, that means for a particular element it has different types of atoms. We know that elements is consist of same type of atoms. That's why it is called simplest form. But on further study, that same element but different atoms, it has different types of atoms. So atoms of the same element having same atomic number and different mass number are called isotopes. Isotopes. What are the examples? You see, let hydrogen. Hydrogen has three isotopes, that H11, H12, H13. There are three types of atoms of hydrogen atoms. These are the known. This is called protium. This is called protium. This is called deuterium. And this is called tritium. Three types of isotopes. Their nature are different. H11, H12, H13. So, if you see, these are the different atoms of hydrogen element having same atomic number 111 but different mass number 1, 2, 3. Mass number are different but atom number is same. Similarly, oxygen has O8 16, O8 17, O8 18, like this. Different types of isotopes of oxygen. Carbon C6 12, C6 14, like this. So different atoms of the same element are called isotopes. For the same element, what are the types of atoms? These are called isotopes. Means same atomic number is same, but mass number are different. These are called isotopes. So what are the properties? If you say, what are the properties? Properties of isotopes. If you just study the properties, first important property is same number of protons. Number of protons are same because atom number is same. Same number of protons but different number of neutrons. This is very important. For the isotopes, protons are same but neutrons are different. Protons are same. This is the first. As the protons are same protons, and that means same valence electron, we can say same valence electron. Same valence electron means same chemical properties. That means same chemical properties. All isotopes, their chemical properties are same because the number of valence electron, outermost electron is same. Atom has cell. Atom has different types of cell. So the outermost cell contains same number of electrons for the isotopes. For all types of isotopes on the same element, particular element, atoms of the same element, they have same number of valence electron. If number of valence electron is same, they have same chemical properties. Chemical properties are same. So these are two important characteristics of isotopes. Then what are the isobars? What are isobars? This is the first important thing. Isotopes. This is isobars. What are isobars? Isobars just opposite. Atoms of the different elements. Atoms of the different elements having same mass number but different atomic number are called isobars. Here in isotopes, atomic number is same but mass number are different. Means subscript number. This is a subscript. Subscript number are different for isotopes. Superscript number are different, but subscript number are same. But in isobar, the subscript number are different, but superscript number are same. So same mass number, but different atomic numbers. Examples, you see. Examples of isobar. For example, carbon 614 and nitrogen 714. If you see, these are two atoms of different element but same mass number, different atomic number. This is one pair, let it be. Another pair, suppose your your argon, let it be argon 18, 40 and your potassium 19, 40. Let it be. Suppose calcium, okay, calcium 20, 40. This is also one pair, that is isobar. Isobar because mass number are same, atom number are different. So these are some important examples of isobar. What are the characteristics? What are the properties? Properties is like this. As different number of atomic number are different, so they have what written? Same number of protons. Different number of protons and neutrons. Protons and neutrons all are differ in case of isobar. Here we'll discuss here proton is 6. Here neutron will be sum of protons plus neutron is 14, means how much neutron? 14 minus 6, that is 8. Here proton is, for example C614. Here proton is equal to 6 and neutron is equal to 14 minus 6, that is 8. But here nitrogen, you see 714, here proton equal to 7 and neutron equal to how much? 14 minus 7, that is 7. You see, all are different. Proton 6, 7, here neutron 8, 7. So in case of isobars, protons and neutrons differ from one another. And another important thing is, what is this? That they have same number electron. No, different number of valence electron. Valence electron are different, so different and different chemical properties. chemical properties are different. Chemical properties are same because same number of electrons. Here different number of electrons. That's why different chemical properties and different valence electron. So these are the isotopes and isobars. Then what are the uses? Let us discuss what are the uses. Important uses, very important common isotopes are used in our day-to-day life. First one is that carbon 14, because carbon having 6, atom number is 6, not necessary to write 6. Carbon 14 used in carbon dating. Carbon dating. What is carbon dating? Determination of age of fossil. Age of fossil. Age of fossil. Age of fossil can be determined using carbon 14. How much year back it was exist. Suppose now you know the fossils of dinosaurs that we are getting from the earth. That indicates from how many years back this type of species was available. So by carbon 14 techniques, that is called carbon dating, we can know the age of fossils. Age of the living beings exist in the many years back. So we can know this thing from the carbon dating techniques. Then second we can take iodine 135, iodine 131, iodine 131 is used in treatment of goiter. Treatment of goiter disease, that thyroid. Treatment of thyroid. Goiter disease, that is treatment of thyroid. That is iodine 131 isotopes. And you know that uranium 235 is used in nuclear reactor. In nuclear chemistry, for the that formation of atom bomb, or you can also use for nuclear bomb techniques, or it is used for that formation of energy, nuclear energy using uranium 35. Very important that elements used in the nuclear reactor, uranium 235. Cobalt 16 is used in the treatment of cancer. Cobalt 16. So large number of isotopes nowadays we are using for our benefits of human being, for the welfare of humanity. We are using so many isotopes. So these are the different composition of elements. We know elements having same number of atoms, but it is studied that same elements have different types of atoms. These are called isotopes. And if you compare the different atoms of the different elements, they may have some similar composition. Example, mass number is same, number of proton neutrons are same, but atomic number is different. Carbon element and nitrogen element, they have same number of similar in behavior. So these are some important properties of what? Isotopes and isobars. Now we will discuss that how to calculate the number of electrons and protons available in the atoms. Okay? Now we will calculation of number of electron, proton, neutron. For example, hydrogen H11, you see, make the table number of electron, proton and neutron. If you draw it, if you make the column, it will be better. Suppose this is, you take hydrogen, this is element. Element is, suppose let it be a hydrogen, H11. H11 means as it is neutral species, number of electron proton always same. So proton is 1, electron also 1. Both 1 because atom is neutral. This is atomic number. Atomic number means number of proton. But as it is a neutral species, atom is always neutral because number of electron is equal to number of proton. Because we have read in Thomson model, the atom is always neutral due to the same number of electron and proton. So proton 1, electron also 1. But what is the, as the mass number is 1, mass number means sum of proton plus neutron. So you can, as sum is 1 and proton already 1, what is the value of n? So n is equal to 0. Because 1 minus 1, that is 0, number of neutron 0. So protium has no neutron. Very important, you note down this one. Very important. Protium isotopes has no neutrons. But if you take deuterium, that is atomic number 1, proton 1, electron also 1. But here mass number 2, so how many neutron? 2 minus 1, that is 1. Deuterium isotope has only 1 neutron. Similarly, you can calculate that carbon C614, how many electron? Electron also 6, proton also 6, and neutron 14 minus 6, that is 8. This is the calculation of what? Number of proton, electron, neutron. But if a ionic species is given, for example sodium, let it be sodium 1123. Let it be take sodium 23. Sodium 23 isotope. Sodium 23 means 11 electron, 11 proton. But how much neutron? 23 minus 11, that is 12. 12 number of neutron. But if we take that, if you take sodium ion, if you take sodium ion of this species, sodium ion of this, you convert this to this. What is this Na plus? How it is produced? It is Na will convert to Na plus by losing single electron. When the atom losing electron minus E, when the atom losing electron become Na plus. When electron is lost, so it has now 10 electron. Because 1 electron lost, that's why sodium becomes sodium plus. So 10 electron. Now, as it derived from 23, mass number will not be changed. Mass number 23. And as electron is lost, but proton is remaining same, that's a proton will be 11. Because proton is the central part of the atom, that is the part of the nucleus, will not be disturbed. That's why proton remaining same, but electron is decreased by 1 because of loss of electron. And your neutron will be same, 23 minus 11, that is 12. It's very important this. For example, chlorine. Let it be chlorine. Chlorine is 1735. 1735. So how many proton, electron? Electron 17, proton also 17. But how much neutron? 35 minus 17, that is 18. That is number of neutron. But if you convert this to Cl minus, convert Cl to Cl minus. Cl to Cl minus means gain of electron. When electron will be added to the neutral atom, then it will be minus sign. When electron will lost from neutral atom, it will become plus sign. loss of electron plus, gain of electron is minus. It depends upon the charge. As it is neutral, when losing electron is plus. As it is neutral, gaining electron Cl minus. Cl minus means number of electron increase. Number of electron will be 18. One electron is added, means 17 becomes 18. But proton will not be changed. Proton remaining same, 17. And neutron also 18, remaining same. So this is about, suppose you convert one thing, that oxygen, for example, if again you convert, suppose Cl plus, Cl to Cl plus, you lose electron from Cl, what happens? It becomes 16. Loss of electron, that means become electron 16, but proton remaining same, 17, and mass number will be 35. 35 minus 17, that is how much? 18. Only change in electron, plus or minus. If plus is increased or plus is decreased, or minus is increased or minus is decreased, only change in electron. Remember, when electron is lost, that is electron will decrease. When electron will be added, then electron will increase. But number of proton, neutron remaining same. This is a very important calculation of the number of electron, proton, neutron available in the atom. So in this way, you can practice more regarding the types of isotopes, isobars, and their properties and their uses, and calculation of electron, proton, neutron in the particular isotopes. These are very important for your exam. Okay? Thank you all.